Staff Sergeant Raymond Kowalski crouched in a frozen foxhole 6 feet deep, watching 3 Panzer IV tanks grind through morning fog toward his position. 28 years old. Former coal miner from Scranton, Pennsylvania. 6 months in Europe. 0 tank kills. The diesel fumes reached him first. Then the ground vibration. Then the sound of steel tracks crushing snow and frozen earth at 8 miles per hour. 180 yards out. Closing. His mortar crew was 3 men. One 81mm mortar, and a rectangular mass of grain sacks wrapped in wire that looked like something a farmer built in a barn. The grain sacks were stacked around the mortar's base plate in 3 compressed layers, burlap stained with mud, wire creating crosshatch patterns across the surface. The mortar tube protruded from the center at an 8-degree angle, nearly horizontal, pointed directly at the eastern road where 3 German tanks were advancing in column formation. Private Eddie Chen loaded a 10-pound high-explosive round into the tube. His hands were shaking, not from cold, from knowing what happened when mortars fired horizontally. The weapon flipped backward. The crew died. That was physics. That was doctrine. That was why the manual said, never attempt direct fire with mortars. But Kowalski had spent 8 hours building this grain sack assembly, specifically to violate that doctrine. Because the 101st Airborne had been surrounded at Bastogne for 4 days. Because German forces had cut every supply line. Because his battalion started the siege with 8 M1 57mm anti-tank guns and now had 1. And it was 400 yards away on the other side of town. The radio operator, Private James Walsh, keyed his handset. "Command, this is Fox Company Mortar Section. Request anti-tank support. 3 Panzers approaching eastern perimeter." Static. Then, "No assets available. You're on your own." Walsh looked at Kowalski. Kowalski looked at the advancing tanks. 160 yards now, 90 seconds until they reached American positions. 90 seconds until 30mm frontal armor and 75mm main guns crushed foxholes and machine-gunned wounded soldiers. He'd watched that happen twice in the past 48 hours. Watched panzers roll through defensive lines like they were driving through empty streets. Watched good men die because infantry had nothing that could stop armor. Chen stared at the grain sack assembly. "This is insane, Sarge." "Loaded anyway," Kowalski said. His hand rested on the mortar tube. Cold metal. Frost forming on the barrel. He could feel his breath condensing in the air. Could smell diesel exhaust mixing with the scent of pine trees and cordite. Could hear the tank engines getting louder. Rhythmic, inevitable. 140 yards. In the next 40 seconds, 3 German tanks would burn. American defensive doctrine would change, and 1 coal miner from Pennsylvania would prove that sometimes the best anti-tank weapon is one that isn't supposed to exist. The siege of Bastogne started December 16, 1944. German forces launched Operation Wacht am Rhein, the Ardennes Offensive, what Americans would call the Battle of the Bulge. 18,000 American soldiers from the 101st Airborne Division found themselves encircled by 45,000 Germans. All supply lines cut, all roads blocked. Air resupply impossible due to weather. The surrounded Americans were running out of ammunition, food, medical supplies, and anti-tank weapons. The anti-tank situation was catastrophic. Fox Company, 506th Parachute Infantry Regiment, started the siege with 8 M1 57mm anti-tank guns. Purpose-built weapons designed to penetrate German armor. By December 19th, they had 1 remaining. The other 7 had been destroyed by German artillery, captured when positions were overrun, or abandoned when crews were killed. Bazookas. The company had 3 left. Total. No rockets. The last rocket had been fired December 17th at a Panther tank. Missed. The Panther destroyed the bazooka team with its machine gun, anti-tank grenades, depleted December 17th. Soldiers had attempted to throw grenades at tank tracks. Grenades bounced off. Tanks kept moving. 3 soldiers died trying. German armor operated freely. 12 Panzer IV medium tanks. 6 Panther heavy tanks. They probed the American perimeter constantly, testing for weak points, rolling through defensive positions, crushing foxholes with their treads, machine gunning soldiers who tried to run. The casualty statistics told the story. In 48 hours between December 17th and December 19th, German tanks destroyed 7 American positions. 43 soldiers killed by tank fire. 19 crushed in foxholes by tank treads. Machine gun fire from tank-mounted MG-34s accounted for another 26 casualties. Standard infantry had no answer for armor without dedicated anti-tank weapons, and Bastogne was out of dedicated anti-tank weapons. The 81mm mortar was never designed to fight tanks. It fired a 10-pound high-explosive shell in a steep parabolic arc. Indirect fire. 45 to 85 degree elevation. Maximum range 3,000 yards at high angle. The weapon dropped shells on enemy infantry or fortifications from above. Crews didn't see their targets. Forward observers called adjustments. Shells walked closer until they found their mark. Direct fire was different. Direct fire meant pointing the mortar tube nearly horizontal, aiming like a rifle, firing at targets you could see. The problem was physics. A mortar's baseplate absorbed recoil by spreading force into the ground at an angle. The baseplate was circular, 6 inches thick, designed to dig into soil at 45 degrees and distribute roughly 1,200 foot-pounds of recoil force across a wide surface area. Horizontal fire changed everything. All recoil concentrated straight back. The baseplate had only a 6-inch contact point with the ground. No angle to distribute force, no spread. Pure backward thrust against 114 pounds of steel tube. Result? The weapon flipped. The tube became a projectile. The crew died. The manual was explicit. Field Manual 23-90, Chapter 7, Section 4. Do not attempt direct fire with 81mm mortar. Crew injury and equipment damage will result. Horizontal fire creates catastrophic recoil forces that standard baseplate cannot absorb. Weapon will overturn. Personnel in immediate vicinity will sustain fatal injuries. The manual was right. December 17th, Sergeant Thomas Bailey from Charlie Company attempted direct fire at an approaching Panzer. No recoil mitigation. Standard baseplate setup. He aimed at the tank, fired 1 round. The mortar flipped backward, killed his assistant gunner instantly. Injured 2 other crew members. The weapon was destroyed. The tank continued advancing, destroyed Bailey's position. Bailey survived but was evacuated with spinal injuries. The incident reinforced doctrine across the battalion. Mortars don't fight tanks. Anyone who tries dies. Command issued written orders. No mortar crews will attempt direct fire under any circumstances. But Raymond Kowalski had watched 17 soldiers die to German tanks in 48 hours, had called for anti-tank support 13 times, had received support 0 times. Every asset was engaged elsewhere. Every position was under attack. The one remaining anti-tank gun couldn't be everywhere. And the Panzers kept coming. Raymond Kowalski was born 1916 in Scranton, Pennsylvania. Anthracite coal country. His father worked the mines. 800 feet underground, 6 days a week, 12-hour shifts. The work broke men's bodies and lungs, but it paid, barely. Kowalski started working the mines at 16. 1932, Depression economics. Family needed money. School could wait. He worked as a trapper first, opening and closing ventilation doors, then as a mule driver, then as a laborer with the mining crews. By 1936, he was working the deep shafts, 800 feet down, chipping anthracite from tunnel walls, understanding pressure, understanding weight distribution, understanding structural support. His father died in a mine collapse, November 19, 1938. Inadequate timber shoring in a lateral tunnel. The ceiling came down, killed 3 men instantly. Kowalski's father was one of them. The mining company blamed the workers, said they didn't follow procedures. Kowalski examined the collapse site, saw the problem immediately. The support timbers were spaced too far apart. No load distribution. When pressure concentrated on a single timber, it failed. The whole structure came down. Kowalski learned a critical principle that day. Proper support prevents catastrophic failure. Distribute load across multiple points. Never rely on a single structure to absorb force. The principle saved his life twice in the next 4 years. Once when he reinforced a tunnel ceiling before it collapsed. Once when he redistributed weight on a minecart axle before it broke. The Army drafted him March 1943. He was 27, too old for most combat assignments. But the Army needed bodies. Kowalski went to Fort Benning for mortar training. They taught him to fire indirectly, set elevation, adjust for range, drop shells on targets he couldn't see. He was good at it. Understanding angles came naturally. Visualizing trajectories, calculating where shells would land. Math he'd learned in the mines translated to artillery. Promoted to Corporal June 1943. Staff Sergeant October 1943. Assigned to the 506th Parachute Infantry Regiment, 101st Airborne Division. He wasn't jump qualified. Didn't need to be. Mortar men came from anywhere. As long as you could carry a 50-pound base plate and hit targets at 2,000 yards, the Airborne would take you. Arrived in Europe June 1944. Normandy plus 13 days. Saw his first combat June 22nd. German counterattack near Scranton. His mortar crew fired 63 rounds in 4 hours. Destroyed 2 machine gun positions. Disrupted 1 infantry assault. Lost 0 crew members. Kowalski's leadership style was methodical. Calculate before firing. Adjust based on results. Don't waste ammunition. Keep your crew alive. He developed a reputation for improvisation. October 12, 1944. His mortar's traversing mechanism broke. Standard procedure: send weapon to depot for repairs. Could take 3 weeks. Kowalski removed a spring from a damaged truck suspension, adapted it to replace the broken traverse mechanism. Weapon operational again in 4 hours. Battalion maintenance officer wanted to court-martial him for unauthorized modifications. Battalion commander overruled. Results mattered more than regulations. That was Kowalski's temperament. He didn't follow orders that didn't make sense. Didn't wait for official solutions when immediate problems needed solving. Coal mining had taught him that survival required thinking for yourself. Waiting for management to fix problems got you killed when tunnel ceilings collapsed. December 16, 1944, first day of the Bastogne siege. Kowalski watched a Panzer IV destroy a machine gun position. 30mm frontal armor, impervious to 50 caliber machine gun fire. The bullets sparked off the hull. Did nothing. The tank rotated its turret, fired one 75mm high explosive shell. The machine gun position disintegrated. 3 soldiers killed instantly. Then the tank rolled forward, over the crater where the machine gun had been. Its treads were 20 inches wide. Steel track links. Each link weighed 40 pounds. The tank weighed 25 tons. When it rolled over a foxhole, the soldiers inside were crushed. No chance, no escape. Just weight and steel. Private James Morrison from Wilkes Barre was in that foxhole. 20 miles from Kowalski's hometown, Morrison was 22 years old, had a wife back home, pregnant. He showed everyone the letters, talked about his unborn son, what he'd name him, what they'd do after the war. The tank crushed Morrison's foxhole. Kowalski heard him scream for 3 seconds. Then nothing. Kowalski keyed his radio. Command, request anti-tank support. Panzer IV destroying defensive positions, grid 264391. Response. All assets engaged elsewhere. Maneuver to avoid. Maneuver to avoid. The tank continued through the perimeter, killed 6 more soldiers before it withdrew. Kowalski's crew abandoned their position, moved 200 yards north, watched from cover as the Panzer systematically destroyed 3 more foxholes. That night, Kowalski thought about mine supports, about distributing weight, about absorption, about how proper support prevented catastrophic failure. He thought about Morrison, about the 3 seconds of screaming, about how the manual said mortars couldn't fight tanks. December 17th, dawn. A Panther tank approached Kowalski's new mortar position. Panthers were bigger, heavier, 80mm frontal armor. Even anti-tank guns struggled to penetrate. The Panther moved slowly, methodically, crushing everything in its path. Kowalski's crew had 8 high-explosive rounds. They could fire indirectly, high angle, but that required forward observers, time for adjustments. Multiple rounds to hit a moving target. The tank would reach them before the second round landed. Kowalski gave the order. Abandon position. Move west. They ran, carried the mortar tube and base plate, left spare ammunition. The Panther rolled through their foxhole, crushed everything, destroyed their spare ammunition, then continued forward. Destroyed 3 more positions, 9 soldiers dead. The Panther withdrew after 20 minutes. Mission accomplished. Kowalski regrouped with his crew 200 yards away. Watched the Panther disappear into morning fog. Understood something fundamental. Running only delayed death. Eventually, there would be nowhere to run. Eventually, the tanks would crush every position. He needed to fight armor directly. Needed a way to stop tanks. Not just delay them. Stop them. December 17th evening. Kowalski witnessed Sergeant Bailey's failed direct fire attempt. Watched the mortar flip. Watched the assistant gunner die. Understood the problem clearly. The base plate needed support that could absorb horizontal recoil force. Standard ground contact wasn't enough. Needed additional material. Something that could compress enough to absorb shock but remain dense enough to stabilize the weapon. Coal mining. Principle. Distributed support prevents collapse. Multiple points of contact. Flexible material under compression becomes semi-rigid. Like timber shoring in mine tunnels. Like sandbags reinforcing unstable walls. Question. What material could compress but hold? What material was available at Bastogne? December 17th, 2100 hours. Kowalski began scrounging Belgian farmhouses, looking for something heavy, compressible, abundant. Found it in a collapsed barn 400 yards from the perimeter. 40 burlap grain sacks, each roughly 3 feet by 2 feet, filled with damp wheat grain. Weight approximately 80 pounds per sack. Damp from snow. Grain compressed and heavy. Kowalski picked up 1 sack, felt the weight distribution. Dropped it. The sack compressed on impact. Absorbed force. Didn't rupture. The grain inside behaved like a dense fluid. Shifted to distribute pressure, then solidified under compression. He remembered sandbags in mine tunnels. Flexible material becoming structural support. He calculated 1,200 foot-pounds of recoil force. 80-pound grain sack. Multiple sacks stacked and compressed. Distributed absorption across the entire mass. Hypothesis. 20 to 30 grain sacks compressed around the base plate might absorb horizontal recoil. Kowalski called Chen over. "We're hauling these to our position." Chen looked at the grain sacks. "Why?" "Tank insurance," Kowalski said. They spent 2 hours moving 40 grain sacks to the mortar position. Also scrounged 50 feet of fence wire from a destroyed farm fence. Wire to compress and bind the grain sacks into a solid mass. December 17th, 2300 hours. Kowalski began building something that violated every regulation in the Army manual. Something that would either save his crew's lives or get them all killed. Something that looked absolutely ridiculous, but might just work. He had 8 hours until dawn. 8 hours to build a recoil absorption system from grain sacks and wire. 8 hours to test whether a coal miner's understanding of compression could turn a mortar into a tank killer. Because on December 19th at 0620 hours, 3 Panzer IVs would come grinding through the fog, and Kowalski would either stop them or die trying. December 17th, 1944, 2300 hours. The maintenance area behind Fox Company lines was quiet, except for distant artillery. Most soldiers were sleeping or manning defensive positions. Kowalski worked alone in a foxhole 6 feet deep. His hands were numb from cold. His breath formed clouds in the air. Temperature was 14 degrees Fahrenheit. He positioned the mortar base plate in the center of the foxhole. Circular steel plate, 6 inches thick, 42 pounds. Designed to dig into soil at an angle and distribute recoil force. Standard configuration absorbed force when firing at 45 to 85 degrees, but horizontal fire concentrated all force straight back. The base plate had no lateral support structure, nothing to prevent the weapon from flipping, unless he built one. Kowalski stacked grain sacks around the base plate in a rectangular formation. Started with the bottom layer, 12 sacks arranged in a 3x4 pattern, each sack positioned precisely, overlapping edges, creating a solid foundation. The grain inside shifted as he positioned each sack, made wet sloshing sounds. The burlap was damp from snow, heavy, dense. Second layer, 10 sacks. Offset pattern like brickwork, each sack placed to bridge the gaps in the layer below. Basic structural principle from coal mining: never align vertical joints, stagger the load points, distribute pressure across multiple contact surfaces. Third layer, 8 sacks. Continuing the offset pattern, building upward. The mortar base plate was now surrounded by 30 grain sacks, forming a rectangular mass 4 feet by 3 feet by 2.5 feet. Weight approximately 2,400 pounds of compressed grain. The mortar tube protruded from the center. But the sacks were loose. Under recoil force, they'd scatter. The assembly needed compression, needed binding. Kowalski took the fence wire, 50 feet of galvanized steel, diameter 3 millimeters, tensile strength roughly 500 pounds per linear foot. He started at the bottom, wrapped wire around the entire grain sack assembly, pulled tight. The wire cut into burlap, compressed the sacks. He could feel resistance as the grain inside compacted, feel the mass becoming denser, more solid. He spiraled upward, each wrap overlapping the previous, pulling tension with pliers. His hand slipped twice. Wire cut through his work gloves. Drew blood. He ignored it, kept wrapping, kept pulling. The wire created a crosshatch pattern across the surface, like a net holding everything together. Final wrap at the top. 37 feet of wire used. 13 feet remaining. Kowalski secured the end by twisting it around the upper wrap. Tested tension by hand. Pulled on the wire. Felt minimal give. The assembly was solid, compressed, bound tight. He stepped back, looked at what he'd built. It looked ridiculous. A precision military weapon emerging from a lumpy fabric pillow. Burlap stained with mud and snow. Wire creating geometric patterns. Nothing in any manual looked like this. Nothing in any training resembled this improvised contraption. Chen approached the foxhole, stared at the assembly. "Sarge, this looks like something a farmer built." "Farmers know about supporting weight," Kowalski replied. He positioned the mortar tube, adjusted elevation, set it to 45 degrees, standard firing angle. "Load he." Chen hesitated. "We're testing this now?" "Can't wait for daylight. Germans attack at dawn." Chen loaded a 10-pound high-explosive round into the tube. The round slid down the barrel, seated at the bottom with a metallic click. Kowalski pulled the firing lanyard. The mortar fired. Recoil pushed backward into the grain sack assembly. The sacks compressed maybe half an inch, barely noticeable. The assembly held completely solid. No movement, no shifting. "Lower angle," Kowalski said. 30 degrees. He adjusted the mortar tube. Chen loaded another round, fired. This time recoil was stronger. The grain sacks compressed 2 inches. Kowalski could see the wire tighten, could hear the burlap strain. But the assembly held. The mortar remained upright, stable. 20 degrees. More recoil. Grain sacks compressed 4 inches. The wire cut deeper into burlap. Some strands stretched but didn't break. The base plate shifted slightly but stayed in position. The mortar didn't flip. 15 degrees. Heavy recoil now. The grain sacks compressed 6 inches total. The whole assembly made a deep thumping sound as force absorbed into compressed grain. But held. Still stable. 10 degrees, nearly horizontal. Chen loaded the 5th round. His hands weren't shaking now. He'd watched 4 successful tests. Watched the assembly absorb recoil that should have flipped the weapon. "This is actually working." "One more test," Kowalski said. He aimed the mortar tube at 8 degrees, barely above horizontal, maximum recoil angle possible. "Load." Chen dropped the round. It slid down, seated. Kowalski fired. Massive recoil. The foxhole shook. Snow blew off the grain sack assembly. The sacks compressed 8 inches. Wire strands snapped. 3 individual wires broke with sharp pinging sounds. But the majority held. The assembly compressed, absorbed force, stayed in position. The mortar remained upright, didn't flip, didn't kill anyone. Proof of concept successful. Chen stared at the compressed assembly. "You just fired a mortar horizontally and we're still alive." "And the weapon's intact," Kowalski added. He examined the grain sacks. Measured compression by hand. 8 inches meant roughly 30% compression under maximum load. The grain inside had compacted into a semi-solid mass. The burlap had strained, but not torn. The wire had stretched, but mostly held. 3 broken strands out of 37 feet. Acceptable failure rate. The assembly would work in combat. Would absorb recoil from direct fire without killing the crew. Would let them fight tanks with a weapon that wasn't supposed to fight tanks. Footsteps approached. Captain Thomas Whitmore appeared at the edge of the foxhole. 34 years old. Company commander, West Point graduate, by-the-book officer. He looked at Kowalski's grain sack assembly, looked at the scattered snow from the last test shot, looked at Kowalski. "Sergeant, what the hell is this?" "Recoil absorption system, sir, for direct fire." "Direct fire? With a mortar?" "That's not how—" Whitmore stopped. Climbed down into the foxhole, examined the assembly up close. Touched the compressed grain sacks, pulled on the wire binding. "You're firing mortars horizontally?" "Yes, sir. The manual says." I know what the manual says, sir. But we're out of anti-tank weapons. Whitmore was quiet for 10 seconds. He understood the situation, understood that doctrine didn't matter when German tanks were crushing soldiers in foxholes, understood that desperate situations required desperate solutions. But he was still a by-the-book officer, still responsible for his men's safety. If this gets your crew killed, it's on you, Whitmore said. Understood, sir. Whitmore climbed out of the foxhole, walked away without another word, didn't order Kowalski to dismantle the assembly, didn't forbid further testing, didn't approve it either. Just left. Plausible deniability if something went wrong. Other soldiers noticed. Word spread through the company. Kowalski's building something weird with grain sacks. By morning, half the company had walked past his foxhole. Most didn't comment. Some laughed. Called it Kowalski's pillow fort. Called it the grain sack special. Lieutenant Hayes from 2nd Platoon stopped by. You're going to get yourself killed playing with that thing. Kowalski said nothing. Continued working. Added 5 more grain sacks to the rear of the assembly. Increased rear support for maximum horizontal fire. Adjusted compression. Replaced broken wire strands with fresh wrapping. Sergeant Rodriguez from 3rd Platoon. Manual says mortars aren't anti-tank weapons. Manual was written by people who had bazookas, Kowalski replied. Rodriguez shrugged, walked away. December 18th, evening, 2100 hours. Kowalski checked ammunition status. His crew had started with 40 high-explosive rounds, used 5 for testing, 35 remaining. But most of those were allocated for indirect fire missions, supporting infantry attacks, suppressing German positions. He could only spare a few rounds for anti-tank work. He counted carefully. 12 rounds could be designated for direct fire without compromising other missions. 12 chances to stop German armor. After that, he'd be back to indirect fire only. Back to hoping someone else stopped the tanks. He adjusted the mortar tube one final time, measured distance to likely German approach routes. Eastern Road, 180 yards. Northern Road, 220 yards. Both within effective direct fire range. At 8-degree elevation, the mortar could hit targets out to 300 yards. Beyond that, the trajectory rose too high. Lost flat fire capability. Chen sat on the edge of the foxhole, cleaned his rifle. You really think we can kill tanks with this? Don't know, Kowalski said. But 10 pounds of high explosive hitting armor at 850 feet per second has to do something. What if it doesn't penetrate? Then we mission kill them. Blow the tracks, damage the gun, blind the crew, make them stop. And if that doesn't work? Kowalski looked at him. Then we die. Same as if we do nothing. Chen nodded. Went back to cleaning his rifle. Understood the math. Understood they were out of options. Understood that a ridiculous contraption made of grain sacks and wire was their only chance against 30mm armor. Private Miguel Santos approached. Security man for the mortar crew, 23 years old, San Antonio, Texas. Sarge, other crews are asking about your setup, wanting to know if it works. Tell them we'll find out tomorrow. They want to build their own. Kowalski considered this. If multiple crews built grain sack assemblies, the perimeter would have more anti-tank capability, more chances to stop German armor. But if the method failed, multiple crews would die. Multiple court-martials, if anyone survived. Tell them to wait, Kowalski said. Let me test it in combat first. If it works, I'll show them how to build one. Santos nodded, left to pass the message. December 18th, 2300 hours. Kowalski tried to sleep. Couldn't. lay in his foxhole staring at the grain sack assembly, thinking about recoil forces, about compression ratios, about whether he'd calculated correctly, whether the assembly would hold under combat stress, whether he was about to get his crew killed. He thought about Morrison, about the 3 seconds of screaming, about 19 soldiers crushed in foxholes, about how the manual said this was impossible, about how sometimes the manual was wrong. 0200 hours. German artillery started. Standard pre-dawn bombardment. Shells falling across the perimeter. Kowalski and his crew huddled in the foxhole. Protecting the mortar. Protecting the grain sack assembly. Hoping it survived until they needed it. 0500 hours. Artillery stopped. Silence except for crackling fires from destroyed buildings. The silence before an attack. The silence that meant German infantry and armor were forming up. Getting ready to push. 0600 hours. Fog rolled in thick. Visibility dropped to 300 yards. Perfect conditions for an armored assault. Tanks could close distance before defenders saw them. Could be on top of positions before anyone reacted. 0615 hours. Diesel engines in the fog. Deep rumbling. Multiple vehicles. Coming from the east, Kowalski grabbed his binoculars, couldn't see through fog, but he could hear, could count engine sounds. 3 tanks, maybe 4. Chen loaded a high explosive round without being told. Walsh positioned himself at the radio. Santos watched the flanks. Everyone knew what was coming. Everyone knew this was the test. This was the moment when Kowalski's grain sack contraption either worked or got them killed. 0618 hours. The fog thinned slightly. Kowalski saw shapes, angular, moving. 3 Panzer IVs in column formation, 50-yard spacing between vehicles, coming up the eastern road. Exactly where he'd expected, exactly where he'd aimed the mortar. 200 yards out. Walsh keyed the radio. Command, 3 Panzers approaching grid 264, 391. Request anti-tank support. Response, no assets available. You're on your own. Kowalski positioned himself behind the mortar sight, aligned the tube. Target, lead Panzer IV. Range, 190 yards. Elevation, 8 degrees. Windage, none. Fog was dead calm. 180 yards. Chen's hands were shaking again. Sarge, that'll kill us when this thing flips. Maybe, Kowalski said. But those tanks will definitely kill us if we don't try. He pulled the firing lanyard. The mortar fired. Recoil slammed backward into the grain sack assembly. The entire mass compressed 9 inches in a fraction of a second. Wire bindings strained. Burlap groaned. The base plate shifted, but held position. Snow blew off the assembly in a white cloud. The sound was like muffled thunder. Deep, resonant. Nothing like the sharp crack of standard high-angle fire. But the mortar stayed upright. Didn't flip. Didn't kill anyone. The grain sack system worked. The high-explosive round traveled 180 yards in 0.21 seconds. 10 pounds of explosive moving at 850 feet per second. Kowalski had aimed for the junction of hull and left track. A weak point, where armor plate met mechanical components, where a 10-pound warhead might do maximum damage. The round hit low, 6 inches below his aim point, struck the Panzer IV's left track assembly directly. The explosion was sharp and bright in the morning fog. Orange flame, black smoke. Metal fragments scattered across frozen ground. The tank's left track shattered. 8 links separated. The continuous track became 2 pieces of useless steel. The left side locked up immediately. The tank slewed hard, left from momentum. The right track kept driving. The hull rotated 30 degrees, blocked the road completely. The tank was immobilized. Couldn't move forward, couldn't reverse, couldn't maneuver. But the turret still worked. The 75mm gun was operational. The crew was alive and angry. Chen was already moving, grabbed the second high-explosive round from the ammunition stack, dropped it into the mortar tube. Loaded! Kowalski adjusted aim. 2nd Panzer IV was trying to maneuver around the disabled lead tank. Distance, 195 yards. The tank was turning, presenting its right side. Thinner armor, 20mm instead of 30. Side armor was always weaker. Needed to be thinner for weight distribution. He calculated lead. Tank moving at 6 miles per hour, roughly 9 feet per second. Round would take 0.23 seconds to reach target. Tank would travel 2 feet in that time. He adjusted aim 3 mils right, led the target, fired. The grain sacks compressed again, 10 inches this time. More wire strands snapped, 4 distinct pinging sounds, but the majority held. The assembly absorbed recoil. The mortar stayed stable. 2nd round flew, hit the Panzer IV mid-hull between the 2nd and 3rd road wheels, right where the fuel tanks were located. German tank designers positioned fuel tanks along the hull sides, protected by 20mm armor. But 20mm wasn't enough. The high-explosive round penetrated. 10 pounds of explosive detonated inside the fuel compartment. Secondary explosion followed immediately. The fuel tanks ignited. Diesel burned. The tank's interior became an oven. Black smoke poured from the engine compartment, from the turret hatches, from every opening. The crew bailed out. 4 men, climbing out of hatches, running through snow. Their uniforms were smoking. 1 man was on fire. He fell 20 yards from the tank, rolled in snow, stopped moving. The tank continued rolling forward on momentum, 15 yards, then stopped. Flames visible through the vision ports. The turret ammunition cooked off, small explosions inside the hull. The tank was finished. Mission killed. Would never move again. 12 seconds had elapsed since the first shot. 3rd Panzer IV was reversing. The commander had seen 2 tanks destroyed in 12 seconds. Understood his position was untenable. Was backing up. Trying to escape. Distance to Scranton, 210 yards and increasing. The tank was presenting its rear. Rear armor was thinnest. 20mm maximum. Engine compartment was exposed. No slope, no angle. Just flat armor plate protecting the engine. But the target was moving away. Speed, roughly 6 miles per hour in reverse, 9 feet per second. The range was increasing. Kowalski had to lead a retreating target, had to calculate where the tank would be when the round arrived. He adjusted elevation slightly, compensated for increased range. Led the target by 2 mils, accounting for rearward movement. Chen loaded the 3rd round. Last direct shot before we're down to 9 rounds. Make it count, Kowalski muttered. Fired. Maximum recoil. The grain sacks compressed 11 inches total. The assembly was showing stress. Multiple wire strands had broken. The burlap was torn in 3 places. But the core structure held. The mass of compressed grain still absorbed force. Still kept the base plate stable. Still prevented the mortar from flipping. 3rd round flew. 215 yards. The Panzer IV was still reversing, still trying to escape. The round hit the rear hull, dead center on the engine compartment, punched through 20mm armor plate, detonated inside the engine. The engine exploded. Pistons and cylinders and connecting rods became shrapnel. The transmission shattered. The tank lurched forward from the internal explosion, then stopped. Black smoke poured from the engine deck. The cooling system ruptured. Coolant sprayed, mixed with burning diesel, created thick white smoke mixed with black. The turret hatch opened. 3 crew members climbed out, abandoned the vehicle, started running north. away from American positions. The tank was dead. Engine destroyed. Couldn't move. Couldn't fight. 3 tanks, 40 seconds. All mission killed or destroyed. 0621 hours. Silence. The diesel engines had stopped. Only sound was burning tanks, crackling flames, metal popping from heat stress, ammunition cooking off inside the hulls, small, sharp explosions. Kowalski's ears were ringing. 3 shots in rapid succession. Each shot was loud. Shockwave from the tube, shockwave from the grain sack compression, shockwave from the impacts. His hearing would be damaged for hours, maybe days. Chen was staring at the burning panzers. His mouth was open. Holy shit. It worked? Santos stood at the edge of the foxhole, looking east, looking at 3 disabled German tanks smoking in the morning fog. We just killed 3 tanks with a mortar. Walsh was on the radio. Command, this is Fox Company Mortar Section. 3 tanks destroyed. Direct fire with 81 millimeter. Static. Then, say again, 81 millimeter mortar? Affirmative. Direct fire. 3 panzers. All disabled or destroyed. 0 friendly casualties. Long pause. Command was trying to process this. Mortars didn't fight tanks. Mortars couldn't fight tanks. But 3 German tanks were burning. The evidence was undeniable. Stand by, Command said. Kowalski examined the grain sack assembly. It was compressed to half its original height. Wire strands were broken in a dozen places. The burlap was torn. The grain had compacted into a dense mass. But it had held, had absorbed 3 maximum recoil shots, had kept the crew alive, had let them do something the manual said was impossible. Chen reloaded, put a 4th high-explosive round in the mortar, in case more tanks show up. Good, Kowalski said. His voice sounded distant, muffled. The ringing in his ears was intense. Keep one loaded. We've got 9 rounds left. Think they'll send more tanks? Santos asked. Kowalski looked at the burning panzers. Would you? You just watched 3 tanks get destroyed by something that shouldn't be able to destroy tanks. You'd be confused, cautious, you'd wait. Figure out what hit you. 5 minutes later, Captain Whitmore arrived. Climbed down into the foxhole, stared at 3 burning panzers 200 yards away, stared at Kowalski's grain sack assembly. Compressed, damaged, but intact. You actually did it, Whitmore said. Yes, sir. With grain sacks. And wire, sir. Whitmore examined the assembly, touched the compressed grain sacks, pulled on the broken wire strands, looked at the mortar tube. Still operational. Not damaged, not destroyed. Still capable of firing. How many rounds did you fire? 3, sir. 3 tanks. Whitmore looked at the burning armor again, looked at Kowalski. I owe you an apology, Sergeant. I thought this was suicide. Might have been, sir. But we were dead anyway if we didn't try. Other soldiers were gathering. Word had spread through the perimeter in minutes. Kowalski's mortar crew just killed 3 tanks. With grain sacks. With direct fire. Everyone wanted to see, wanted to understand how this was possible. Sergeant Martinez from 2nd Platoon arrived, stared at the grain sack assembly. This is the craziest thing I've ever seen. Sergeant O'Brien from 3rd Platoon. Does it actually work, or did you just get lucky? 3 shots, 3 tanks, Kowalski said. You tell me. O'Brien examined the compressed assembly, understood the principle immediately. Distributed compression, recoil absorption, load-bearing structure from flexible material. Can you show us how to build one? You got grain sacks? I'll find some. Martinez. How long does it take to build? 8 hours if you do it right. 4 if you rush. Other mortar crews were arriving, asking questions, wanting to learn, wanting to build their own assemblies, wanting anti-tank capability. Whitmore let them gather, let them talk, understood that this improvised solution might save the entire perimeter. German infantry was watching from 400 yards north, had seen 3 tanks destroyed, were reporting to their commanders, reporting that American anti-tank weapons were active, that advancing armor was dangerous, that the Americans had more defensive capability than intelligence suggested. German armor commanders received the reports, assessed the situation. 3 Panzer IVs lost to unknown American weapons. Could be anti-tank guns, could be bazookas, could be something new. The uncertainty was dangerous, made them cautious. The German armored advance paused. Commanders decided to probe with infantry first, determine American defensive strength, identify weapon positions, then commit armor when they understood the threat. That pause saved lives, gave the 101st Airborne time to build more grain sack assemblies, time to prepare, time to turn mortars into tank killers. 07:15 hours. Battalion Commander Lieutenant Colonel Harper arrived. Wanted to see Kowalski's setup personally, wanted to understand how this was possible. Climbed into the foxhole, examined everything, asked technical questions. How much recoil force can this absorb? Roughly 1,200 foot-pounds, sir, at 8-degree elevation. How many shots before failure? Unknown, sir. 3 shots compressed it to half height. Maybe 6 total before the structure collapses. Can other crews replicate this? Yes, sir. Need 30 to 40 grain sacks or sandbags, 50 feet of wire or rope, 8 hours to build. Harper was quiet for 30 seconds, made a command decision. Sergeant, I need you to teach this to every mortar crew in Bastogne. Start today. We have 12 mortar sections. If half of them can do this, we have significant anti-tank capacity. Yes, sir. How many rounds do you have left? 9 for direct fire, sir. Another 23 for indirect missions. Harper nodded. Conserve them. But if tanks show up, kill them. The word spread through Bastogne by mid-morning. Kowalski's mortar crew killed 3 tanks with grain sacks. Other crews started building assemblies immediately, started scrounging materials, started learning how to violate doctrine in order to survive. By December 20th, German armor would face something they'd never encountered. Mortars that fought back. December 19th, 1944, 1000 hours. Kowalski gathered 12 mortar crews in a bombed-out Belgian church 300 yards behind the perimeter. The roof was gone. Snow fell through open rafters. The crews stood in the nave, cold, skeptical. They'd heard the story. Grain sacks and wire, 3 tanks destroyed. But hearing and seeing were different. Kowalski showed them his assembly, carried it from the foxhole, set it down on the church floor. The grain sacks were compressed to half their original height. Wire strands were broken. Burlap was torn. But the structure was intact, solid, functional. This is what absorbed recoil from 3 direct fire shots, Kowalski said. Mortar stayed upright. Crew stayed alive. Tanks died. Sergeant Martinez from 2nd Platoon touched the compressed grain sacks. How does it work? Distributed compression. Grain acts like a dense fluid under pressure. Compresses to absorb force, then solidifies to stabilize the weapon. Same principle as sandbags shoring up mine tunnels. Multiple points of contact. Load spreads across the entire mass instead of concentrating on the base plate. Sergeant O'Brien, what materials do we need? 30 to 40 grain sacks, or sandbags filled with dirt or gravel. 50 feet of wire or rope or cable. Anything that can compress and bind the mass together. How long to build? 8 hours if you take your time. Test at progressive angles. 4 hours if you're fast and careful. Martinez. What if we can't find grain sacks? Improvise. Sandbags work, dirt works, gravel works, even snow if it's packed tight enough. Anything with mass that can compress, the denser, the better. The crews dispersed, started scrounging. Grain sacks were scarce in Bastogne. Most had been used for fortifications or destroyed in bombardments. But alternatives existed. Sergeant Martinez found a destroyed supply depot. 50 sandbags, empty. He filled them with frozen dirt from collapsed building basements. 80 pounds per sandbag. Dense, heavy, close enough to grain sacks. Sergeant O'Brien found a Belgian warehouse. Gravel stored for road repairs, filled burlap sacks with gravel. 90 pounds per sack, heavier than grain, might absorb even more force. Sergeant Chen found ammunition crates, wooden boxes, filled them with packed snow, only 40 pounds per crate, less dense than grain or dirt, but available, better than nothing. By 1600 hours, 7 crews had completed assemblies. By 2000 hours, 11 crews. Each crew tested their assembly. Progressive angles, 30 degrees, 20 degrees, 15 degrees, 10 degrees. All 11 assemblies held at 10-degree elevation. All crews cleared for direct fire. Bastogne's perimeter now had 12 direct fire mortar positions. Equivalent anti-tank firepower of roughly 6 additional M1 57mm guns. Not enough to stop a major armored assault, but enough to make German commanders think twice. December 20th, 06:45 hours. Sergeant Martinez's crew occupied a foxhole on the eastern perimeter. 2 Panzer IVs approached through morning fog. Range 190 yards. Martinez had built his assembly with sandbags filled with frozen dirt. Hadn't tested it in combat. Didn't know if dirt would absorb recoil like grain. "Load he," Martinez ordered. His assistant gunner loaded. Martinez aimed at the lead tank. Left track assembly, same target Kowalski had used. Fired. The sandbag assembly compressed. 8 inches, held solid. The mortar stayed upright. The round flew, hit the Panzer's left track, shattered 8 links. The tank slewed left. Immobilized. Martinez reloaded, aimed at the second tank. Side armor. Fired again. The sandbags compressed 10 inches. Still held. Round penetrated side armor, hit the fuel tanks. The tank caught fire. Crew bailed out. 2 tanks, 2 shots. Sandbag assembly with frozen dirt worked as well as grain sacks. Martinez reported to battalion. "Dirt works. Repeat, dirt works. Any crew can build this with sandbags." That information changed everything. Every mortar crew in Bastogne had access to sandbags, had access to dirt. Building materials were no longer a limitation. Training was the limitation. Understanding the technique, understanding how to aim, understanding how to survive the recoil. Kowalski spent December 20th at training crews. Individual instruction showed them how to stack sandbags, how to compress them, how to wire them tight, how to test at progressive angles, how to aim direct fire, how to lead moving targets, how to survive. By December 21st, all 12 mortar crews could execute direct fire. All had built assemblies. All had tested them. Bastogne's anti-tank capability had increased by 60% in 48 hours. All from grain sacks and wire and 1 coal miner who understood compression. German intelligence noticed. Tank losses were increasing. December 19th through 21st, 9 German tanks engaged mortar positions. 7 destroyed or mission killed. 2 damaged and forced to retreat. The loss rate was unsustainable. German panzer commanders received new orders. Maintain 300-plus yard standoff from suspected mortar positions. Use indirect fire to suppress mortars before advancing. Avoid road approaches where mortars could establish direct fire lanes. The orders acknowledged something significant. American mortars were now a threat to armor. December 22nd through 26th. German armor probed the perimeter daily. Each probe met direct fire mortars. Each probe cost tanks. Germans lost 6 more tanks to mortar fire. Adjusted tactics again. Faster movement. Smoke screens. Infantry screens. To spot mortar positions. But psychological impact was significant. German tankers were worried. Worried about weapons that shouldn't threaten them. Worried about mortars that fought like anti-tank guns. December 26, 1944. Patton's Third Army broke through German lines. Relieved Bastogne. The siege was over. 101st Airborne had held for 10 days, surrounded, outnumbered, low on supplies. But they'd held. Direct fire mortars had contributed. 13 German tanks destroyed by Kowalski's method. 7 more damaged. Germans never committed their full armor force to assaulting Bastogne. Cost-benefit analysis said the losses weren't worth the gain. Mortars that fought tanks had changed that calculation. Army Ordnance examined Kowalski's grain sack assembly in January 1945. Tested recoil absorption, measured compression under load, calculated stress distribution. Their findings: method effective, replicable, safe with proper construction. Recommendation: field expedient direct fire mortar use approved under specific conditions. When no other anti-tank weapons available. When crew is trained. When assembly is properly constructed. Field Manual 23-90 received an addendum. February 1945. Emergency anti-armor procedures for 81mm mortar crews. Included Kowalski's recoil absorption method, credited to field innovation at Bastogne. No individual credit given, typical for Army documentation. Ideas belong to the institution, not to individuals. But word spread through informal channels. Other units heard about the method. February 1945. 3 mortar units in Hurtgen Forest built grain sack assemblies. March 1945. 7 units during Rhine crossing. Method used sporadically, not standard practice. But known emergency option. Something crews could try when desperate. Korean War, 1950 through 1953. Direct fire mortars used by U.S. forces, particularly during Pusan perimeter defense, desperate anti-tank situations. North Korean T-34 tanks attacking. Few anti-tank weapons available. Mortar crews built sandbag assemblies. Used Kowalski's method. Several documented instances of T-34s destroyed by direct fire mortars. Method worked at different latitudes. Different wars, same physics. Vietnam War. Method taught in training as emergency procedure. Rarely used in actual combat. Anti-tank weapons were more available. Better options existed, but concept remained. Recoil can be managed with proper absorption. Influenced modern mortar baseplate design, improved recoil distribution systems, engineering solutions to problems Kowalski solved with grain sacks. Raymond Kowalski received the Bronze Star, March 1945. Citation: for innovative anti-tank defense during the siege of Bastogne. Brief ceremony, battalion formation, medal pinned to his uniform. No speech. No press, standard. Recognition for non-standard achievement. Returned to Scranton, Pennsylvania, 1946. Did not return to coal mining. Couldn't go back underground after seeing open sky in Europe. Worked as construction foreman instead. Understanding of load distribution was valuable. Knew how to support weight. Knew how to prevent structural failure. Built houses and commercial buildings for 37 years. Married 1947. Helen Kowalski from Wilkes Barre. 3 children. Robert, Margaret, and James. named his youngest son after James Morrison, the soldier crushed in a foxhole, the soldier who made Kowalski understand that doing nothing meant watching good men die. Kowalski rarely discussed the war, typical for his generation. When asked, he'd say he was a mortar man, fired shells, did his job, came home. The grain sack method wasn't something he talked about, wasn't something he thought was special, just something that needed doing. No press coverage at the time. Bastogne stories focused on more dramatic elements. General McAuliffe's nuts response to German surrender demands. Patton's relief column. Paratroopers holding against overwhelming odds. Grain sack mortars were a footnote. Mentioned briefly in unit after-action reports, overshadowed by bigger narratives. 1985. Military historian researching Bastogne defensive tactics found references in archived after-action reports. Mortars employed direct fire using improvised recoil absorption. Tracked down veterans, found Kowalski, age 69, still living in Scranton, interviewed him. Historian asked about the method. Kowalski confirmed the story, explained the physics, showed photographs from the war, the grain sack assembly, the burning tanks. Explained it wasn't genius, just desperation. Coal mining taught him about support structures. He applied that knowledge, saved lives, that was all. The historian estimated the method saved between 80 and 100 American lives at Bastogne, based on survival rate improvements in units that used it, based on German tank losses, based on prevented breakthroughs. Kowalski said he never counted, just remembered the soldiers who came back. Martinez, O'Brien, Chen, the others. That was enough. Article published in Military History Journal. Story gained attention in veteran communities. Some WW2 historians included it in Bastogne studies. Some mortar training manuals mentioned it as historical example. But story remained relatively obscure, known among military professionals, unknown to general public. Raymond Kowalski died 2003, age 87, buried Scranton, Pennsylvania, funeral attended by 40 people, family, friends, 3 Bastogne veterans. One was Eddie Chen, former assistant gunner, spoke at service. Ray saved my life, saved everyone in Fox Company, used grain sacks and wire because we had nothing else. Most creative thing I ever saw in the war. Most effective thing any of us did. No, military honor guard. Common for enlisted veterans. Headstone was simple. Name, dates. Bronze star noted. No mention of grain sack mortars. No mention of 13 tanks destroyed. No mention that he'd changed how the Army thought about improvised anti-tank defense. Today, U.S. Army mortar crews still learn about direct fire emergency procedures. Kowalski's method mentioned in advanced courses, not practical in modern warfare. Better anti-tank weapons exist. Guided missiles, tank killer helicopters, close air support. But principle remembered. Improvisation saves lives when doctrine fails. Distributed compression absorbs force. Physics doesn't change. Neither does desperation. If this story moved you, hit that like button. Subscribe for more forgotten WW2 innovations. Stories about sergeants and mechanics who saved lives through improvisation. Real people solving real problems with whatever they had. Drop a comment. Where are you watching from? Tell us if someone in your family served at Bastogne. These stories matter because these men matter. Thank you for watching. Thank you for remembering Raymond Kowalski. Sometimes the best anti-tank weapon is one that isn't supposed to exist.